Hello friends, welcome back to our channel. In this video, we are going to know how rocket engine actually works and many more unknown facts about rockets. Come on, let's move to the video. So there are two main categories of rocket engines, liquid propellant rockets and solid propellant rockets. So in a liquid rocket, the propellants, the fuel and the oxidizer are stored separately as a liquid and these are pumped into combustion chamber where the energy created and pushed to the nozzle where burning occurs. In a solid rocket, the propellants are mixed together and packed into a solid cylinder. Once the burning starts, it proceeds until all the propellant is exhausted. You have to destroy the casing to stop the engine. But with a liquid rocket, you can stop the thrust by turning off the flow of propellant. Liquid rockets tend to be heavier and more complex because of the pumps and storage tanks. The propellant are loaded into rocket just before launch, but in a solid rocket is much easier to handle. Its propellant can be filled for years before firing. Commonly, solid rockets are attached around the main rockets as a boosters for a extra quick speed. Once its propellants are exhausted, it will be separated from the rockets. Those parts will be collected by the officials once it's landed in the Pacific Ocean and it will be reused for the future projects. So liquid propellant rockets are the most common and effective engine used in the space rocket. Now we will see how it's working. The first part of the rocket is payload. For a rocket, payload can be a satellite, space probe, or a spacecraft carrying humans, animals, or cargo. It depends upon the objective of the mission. The second part is fuel tank. In the fuel tank, liquid hydrogen will be stored, and in the oxidizer tank, liquid oxygen will be stored. Liquid oxygen must be maintained below minus 183 degrees Celsius and liquid hydrogen needs to be maintained below minus 252 degrees Celsius. So that means the fuel must be handled carefully and also the containment tanks must be able to withstand these extreme pressures. On an average, 14,76,310 liters of liquid hydrogen and 5,48,884 liters of liquid oxygen are stored in a space rocket. With this capacity of liters, we can fill 35,660 cars fuel tank. Based on the size of the rocket, the storage of liters will increase even more. Liquid hydrogen and liquid oxygen pumps into the combustion chamber. There the piston compresses the fuel and air mix and those mix will be ignited with a spark plug. Those mixture is combusted and pushed out of the combustion chamber into a form of energy. Controlling valves which helps to control the flow of the fuel into the chamber. So it can be adjusted by increasing or decreasing the thrust as per the atmospheric pressure. The energy of combustion chamber reaches the throat. Because of its neck-shaped design, the energy will be multiplied and pushed to the nozzle with the massive power. Once the thrust reaches its full power, rocket will start to lift off. Rocket engines normally works based on the Newton's third law. For every action, there is an equivalent and opposite reaction. When a rocket is active, temperatures in the main engine combustion chamber can reach up to 3300 degrees Celsius. At these temperatures, metal will melt like a chocolate. But how does rocket engines are not melting? Well, engineer found a simple solution to solve this big problem. Since we are using the coolest propellants on earth such as liquid nitrogen and liquid oxygen, engineers kept a spiral shaped tubes throughout inside and outside of the engine where the liquid nitrogen and oxygen are mixed together and pushed through those tubes before it reaches the combustion chamber. It will maintain the temperature of nozzles and engines between 50 to 55 degrees Celsius. This is how the rocket engines are not melting even at this extreme temperature. When a space rocket is launched, its sound will be so loud. Sound waves can generate up to 220 decibels, which is almost as loud as a nuclear explosion. These sound waves can even damage or sometimes destroy the rocket parts. To avoid this, a sound suppressor system is built into the launch pad. This system uses water to absorb the sound waves from the rocket when it launches. You have seen a huge amount of smoke around the rocket when it's launched. Actually, they are not smoke, they are steam, water vapors. It's formed because all the water are evaporating under the powerful thrust created by the rocket fuel. Once the rocket lifts off, it doesn't maintain a straight trajectory. It lifts off vertically, but around a couple of minutes, it starts turning and going in sideways. This has been deliberately done for two reasons. First, this technique will use the gravity to steer the rocket, as this will save the fuel consumption. Secondly, it creates an aerodynamic position that will escape shuttle from the immense air pressure. Imagine if a rocket continues to fly in a straight path. Due to this immense air pressure, rocket uses more thrust power. This will exhaust all the fuel from the rocket in the halfway before it reaches its destination. The nozzle can move from side to side. With this, they can control the direction of a rocket. Firm insulation sprayed on the rocket's outer body. This insulation helps the tank to act as a thermos bottle. It will protect the rocket from extreme heat occurred due to the air friction. This will also keep the super cold propellants from evaporating too quickly. It also helps to prevent ice forming on the tank's exterior and promotes the right aerodynamic shape for launching into the space. It is calculated as a space shuttle needs to escape from Earth's gravitational pull. The space shuttle speed must be around 28,000 kilometers per hour, which is 23 times faster than sound. NASA's Parker Solar Probe spacecraft is the fastest man-made object ever recorded. Roughly, space shuttle traveled around 692,000 kilometers per hour. So friends, hope this video is informative for you. In our next videos, we will see how do rocket travel in space, how it's reaching another planet, how far we have traveled into space, and more cool stuffs. Support us by subscribing to our channel, and don't forget to like and share this video. See you all in our next video. Bye.